So if you want to control their intake, there's only one person that's done that. So it's really hard to do, to justify a lot of tables on the day. All right, I have one last question about the study. Maybe I should put boring studies so far now. I have one last good question about the study, and then we're going to go to R. So it's not the best example for R, you'll see that, but I just wanted to show you an example that I thought you'd find was interesting, maybe it was too interesting. But Koi asked, well, what about diet? Why can't I put that in my study, that I'm going to have people work out and they're going to reduce their diet? Well, you can't control someone's diet unless you actually control their life all the time. So you're going to have them in-house and restricted. And there's only one study that's ever been done like that, and that was the guy who ran the Heritage study. He actually ran another study where he had people in-house, in residence, in cabins. He watched over what they ate, and he exercised them. And he said, I couldn't let them out, because if I let them out, they would eat. So to hold someone, to clamp someone's diet, and then try to get those calories through exercise, it's really hard.
At this point, it's like, why even help them? Like,
you're being recorded.
Well, I don't care. It's like, they literally have to, if you have to be locked up to do something, like literally locked up and have your natural rights taken away from you in order to better your health, then do what you want. Like die at 30 from a heart attack. Like that's on you, brother.
Are you nice to your plebe? Just to ask.
Yeah, like it's
fat, I would be gross.
Yes.
You know what?
If my plebe was failing,
it's a really complicated.
I would have no sympathy for him.
Like last year, my leader made sure I knew I was not the standard every day. Like you are not the standard. Like you are way overweight. I'm like, thank you, I appreciate that. But like he was not shy about it at all. Like,
you just have to do something. Like if I have seen D tackles in the NFL who are 390 pounds like jump like 6 feet in the air and do amazing things. It's because they move their body. If they can control their diet, they work out, they get out there, they do it themselves. If you're a regular person who's doing nothing, you're 400 pounds, and in order for us to be able to get you to eat right, you have to be locked in a building. And if they knew if you let you out for 1 minute, you would go stuff food down your throat, there is no point helping that person. I would have let General Milley know that you're going to solve the Army's obesity problem.
Can we carry on?
Yeah, we can carry on. This is for the product. Next time I'll take a boring study.
Off what he said, like, my dad is like obese, like fat. Okay, and my mom said, she's like, look, if you don't lose weight, like I will not do it anymore. And he's like, okay, and that motivated him to lose weight because like he just got off his butt, started working out. He lost like 200 pounds in a 1 year span. So let's take their spouse.
All right, this one you got to get Psych on yours because Psych I think gives you a lot of the stuff that you need in an easy way. So somehow today, uninstall R, reinstall R, and get the Psych command on there. All right, first step. We're going to use this eMechanic data set, which the point was that it was an interesting study. I'm going to put in the most boring study next time for my example. Okay, the file's called eMechanic. I'm going to send it to you. The first thing I had to do is I had to make new variables. So all I'm trying to test out is what predicts fat loss. Really one of the interesting things about exercise, it does make you lose fat. So you might rearrange things in your body, you might end up the same weight, but you do end up losing stuff right here at the middle. And so I wanted to see if there was a difference in fat loss, percent fat loss, between the two groups. I'm going to have you recreate everything with lean so that you're doing the same thing as I'm doing. I'm going to send you this. So the first thing is I needed a percent fat mass at baseline and percent fat mass at endpoint of the study. I think it was a 1 year study. It was a 6 month study. And so I mutated these two columns. We've done this before. This is the command. You're just going to have to recreate it for your percent lean. Walking actually makes you lose muscle. So you'll see a decrease in percent lean. And then I had, just like the change score for the reaction time for the study that I just showed you with sleep restricted and unrestricted, sleep deprived and unrestricted, you could have a similar percent fat change score. So I did it as final to baseline. So at the beginning of the study, end of the study to beginning. So if they lost fat, what sign should that be? if they lost fat.
What do you mean, positive or negative?
Yeah, it should be positive or negative?
Positive.
Would it be negative?
It would be negative, right? And so the way I have it here. So these two mutate commands make two new columns. You see, I have to like load this data in. So in data here, when I look over, I always check it just to make sure that what my columns are what they're supposed to be. There's no percent fat mass here. Nothing's here. So once I do this, these mutate commands, what they do is they actually put those columns in there as if you were putting them into Excel. So Control Enter, Control Enter. And so if I go back to this data file, I'm going to see over to the right, there's now the change in percent fat. And so wherever it's negative, somebody lost percent fat, and wherever it's positive, they were on the increased percent fat study. So this plot is a nice plot to have in your work, in your project. I've shown you this before. There were 3 different groups. 0 was the controls, 1 was the low dose of exercise, 2 was the high dose of exercise. And I just want to see if percent fat, the change in percent fat was different by looking at it. And you've seen this before. And you can see that these guys changed more percent fat, but there's more scatter. So this was the group that had the high dose of exercise. But as expected, from doing aerobic, any kind of aerobic exercise, it does take out your middle. That's what it does. It might not make you lose weight, but you will lose your... In fact, the guy that was on the treadmills, like watching, making sure that they did that, he said that. They were the happiest folks when they were on the treadmill. They didn't want to get on there, but once they're on there, they're really happy, and they ended up losing... You could see that their pants were fitting better, but they didn't end up losing weight. Question?
Is there like a median, like a weight in your natural weight your body like tries to...
That's a set point theory. So you guys are bringing up the big theories all in one day.
Is that not the theory?
That's actually the theory, set point theory. All right, so this one here. Some of you are going to try to use the describe command, and I sent you these huge Excel files with lots of variables in it. If you do the describe, it'll send you a data dump of all the variables. If I only want a few variables, then I need to just put those, use the select command. I call it my variables, that new file, and just the command, the columns I want to preserve. So I'm just showing you an example so that you have this code for your own project. And if you do that, and do describe that, it'll only give you the data that you have in that smaller file. So here what it gives you is, it gives you the means, standard deviations, all kinds of stuff in this one column, just for those few variables that I needed. All right, so I think you guys have a huge file with lots of variables in it. You'll probably want to use something like this so you can get your summary statistics coming out with just, and I think who else has the admissions data? You guys have it? Yeah, something like this will restrict it, so you're only getting the output for the variables you need. All right, this is the big one. The LM model, this is what this project is about. It's about doing linear regression. And so this is the command that you have for getting that LM model inside is that formula. You need that formula. And so I put in just what group they were in, whether they're in control 1 or 2, low dose, high dose, and their age, because you're required to have more than one variable. That's one of the requirements of the project. So I've done this with you already. If I do attach your data, do this, and do summary, I get all the stuff about this model right here. I know this is boring, but I'm trying to help you. I really am, because they're not doing this in the other sections, and I don't know if I'm supposed to be doing this. I'm using my civilian powers to do this.
Yes.
But, I need to have you pay attention. I spent like 2 hours making this thing so that it looks nice for you yesterday.
When will this be on YouTube?
Immediately.
Okay. Awesome.
All right, so in your project, you're supposed to make scatter plots. There is the R tutorial that they have. I have the code written here so that you have the line, the trend line in there, and everything together. So all this is coming together, and I show you, like, I took the information from here and I put it into here. The R square is 0.05, which is not that big actually. And I put the line in here too, so that it shows up inside the graph. So this is the command. So it's not, why I say it's not a good data set is we had a few outliers in the third group. They lost a lot of percent fat compared to their peers. They might have been restricting their diet or doing something that the researchers didn't have control over. So it makes the graph look ugly. So this is just a how-to. This is how to get the scatter plot in here. So you guys are required to do the scatter plot, and there's also a requirement that it's individual work when you actually do the results of the study. So this stuff has to be done by each person. You can't hand it over to Allie and make her do all the R coding. You also were asked to look at correlations between variables. You guys are talking about correlations. So I just took my variables because it's a smaller set. And it'll give you the correlations between each one of the variables. Group to group is 1 because they're the same. But the gender is negatively correlated. I think 2 must be males. And so the males were losing more percent fat than females. That's what this is saying. So you can kind of see from this, that's one of the requirements that you have for the project is to come up with this correlation table with your variables. That's how you do it. Preserve what you want in the columns as my variables, and you'll punch that in. Next one. How do you check the assumptions? So using linear regression, you have to satisfy assumptions first. The first assumption is that the error has to look a certain way. So you need an error command. Like you need an error. What I think of error, I think of linear regression as being just a prediction model. That's not a right way to think of it. It's a math way to think of it. So this is a prediction. If I put in age and I put in the group, it's going to spit me out how much they've changed percent fat. So that's how I'm thinking of it. It's not really the right way to think of it. It's like a sloppy way to think of it. But if I want the error in that prediction, I take their actual change in percent fat and subtract off what the prediction is. So that's what this command does. It gives me a new column that's telling me the error. That's not really called error. The big person word for that, the adult word for that, is residuals. So this is called the residuals. So I'll put that as a comment here. So in your book, when they're talking about residuals, that's what they mean. It's just that I think of it as error. I got a model, it predicts. I got a natural value. The difference between the two is the error. It's a really mathy way to, but the name of it's called the residuals. So if I add this in here, I get a new column in the data. In that last column over here, you see error. So sometimes my model overestimated and sometimes my model underestimated. That's a math way to think. It's more like the Jedi math program where they're talking about predicting something all the time. So I have to get the error command in there. I have to get it in there. And Major Adams explains how to do that in the tutorial. I'm going to send you this template. So it's there. This is what you do, and you'll have to change around your variables and your letters. The second thing is you have to look at the histogram of the error. So now I have a column that's called error. The error has to be normally distributed. So if I look at that, it doesn't really look normally distributed. It's right-leaning. It's left skewed. And so that's why I said this is a bad example, because things don't work out, but I'm driving on. Then the next thing is that you want to check for what I call the trend in the error. There should not be a trend in the error. It should be like distributed randomly around 0. You want the error to kind of level around 0. So I have to take my predicted values and my average between these two things. And I run a linear regression model between my error. So this thing is the error with the average value as the x coordinate. And when I plot that, if I do the summary and the trends, there is, see this r square? It's supposed to not be high, and it is high. So there is a trend in the error. That's bad. But I already saw from the histogram. So I'm violating all the criteria to do this. I'm not allowed to do this. So that's, I told you it was a bad example. So that number, that p-value for that trend in the error should be not high. There should not be a good model for that. And you see there is a trend in the error. Here's the error on the y-axis, and here's the average on the x-axis, and there's a clear trend in the error. That's a no-no. That's a violation of what they call the validity condition. So if you find that in your data, that's okay. Just say it like I did. I'm not really allowed to do this because I've not satisfied the validity condition. So I conclude, I write it here that in my example, that I've not satisfied the validity conditions. The error was not normally distributed, and there was a trend in the error. Both are bad. Plus, it's not, well, it is kind of around 0, right? Like, but it's not good. You can see that it's not good. It's supposed to kind of be randomly scattered around 0. And some additional plots they have. This one he has in his notes. So I went to exactly what he was looking at. Again, it's a bad example because of these outliers down here that lost a lot of percent fat. But these are like 95% confidence intervals that are smooth. They're called smoothing curves. So and they'll do it separately. So this 0 was how much fat the control group lost, which you expect them not to lose anything, so it's flat. The green is how much percent fat the first group lost, the low dose, and of course you'd expect more percent fat loss and less. It's not wild. You're not going to lose a lot of percent fat from walking. You just won't. You have to increase the intensity, but you probably have to lower your weight first. If you're that heavy, lower it first and then start sprinting.
Yeah, what is the shaded region of that?
So they're not separated. In the one he has in his tutorial, you can see they're separated. And they're like a 95% confidence interval band around every point. So it shows you the variation that you'd expect. That line is not the actual thing. There's like variation in that too. So it gives you that variation. So that's a shaded area. So these are graphs that you're being asked for the project. And I don't think we'll have time to start, but get started. I want you to do the same thing for percent lean, percent fat free mass. So it's a different variable, but I want you to recreate this so that you know how to do it. So yeah, at least open up R and get started on it. I'm gonna shoot this over to you.